Okay, SA16A number 1. Asked to find, we're given this circuit diagram and asked to find the voltage across and the current through each of the resistors. I see these two resistors are neither in series nor in parallel. They might look like they're in series, but we get something connected to the junction that connects the two ends together. So we'll try Kirchhoff's voltage law and Kirchhoff's current law if necessary. Remember, to get started on those, we define some currents. I think I'll call this one I1. And it splits up here. I'll call that I2. And conceivably we got, we'll have an I3 here. And then based on our choices of current directions, we define the high side and the low side of each of the circuit elements. I need the current directions first to get those. This is just convention. The short side is the low side and the long side is the high side. I'm not looking at the current at all for that. Short side, the low side, high side. I could go ahead and give these some names. I'm going to call the voltage across R1 V1. These script E's used to label the potential difference maintained by a seat of EMF alternative form to just a V1 and an V2 there. Script E stands for EMF, but it's convenient in that then you can use the symbol V1 up here, for instance, for the voltage across the resistor R1, and V2 for the voltage across resistor R2. Would have had to use V sub R2 if this was labeled V1. Okay, then I want to apply the loop rule. So define a loop here. Go around this small one inside. I'll call that loop 1. And I'm going to start here. Call that loop 2. All the way back. So I'm headed up in that direction. And then I'm ready to start analyzing it. So KVL on loop 1 yields, let's say I got a minus V1 and then plus E2. Okay, normally I'd be substituting a current for that, but I see there's only one unknown in this whole equation, so I can go ahead and solve it for the unknown. V1 is equal to E2. In other words, V1 is equal to 12 volts. So that's one of my answers. That's the voltage across R1, and that's one of the things we asked for. And then now that I got that, I can use V1 equals I1 R1, where V1 is the voltage across R1. R1 is, of course, the resistance of R1. And then V1 is equal to, I don't know if I want to go ahead and solve for I1. I'll give myself a little more room here, too. So I1 is then V1 over R1, which is V1 we found to be 12 volts. And R1, 240 ohms. That turns out to be 0.050 amperes, right into 2 sig figs. Okay. Now let's look up at the second loop here. On loop 2, I'll do KVL on 2. I get, say, a minus E2. Keep working my way around. I get a minus V2. So go from high to low. And then this one's from low to high, so plus E1. And that's all. Then back to the start, so equals 0. So V2 is E1 minus E2, which is 16 volts minus 12 volts. Or 4 volts. V2. We can frame that, and that's one of the answers that we're looking for. And then following up on that, we got for the current through R2. Now that I know V2 and I got R2, I can use Ohm's law. So V2 equals I2 R2. I2 equals V2 over R2, which is 4 volts. Just 4.0, get it to 2 sig figs. But, well, actually we were okay there. It's actually only good to 1 sig fig, the difference between those two. So 4 volts divided by, I think I'll erase that. R2, that's 360 ohms. So I really only know the voltage to 1 sig fig, so I think I'll write the answer down to 1 sig fig. I get 0.01 amperes, just the 1 sig fig there. That's all I asked for was the voltage across and the current through each resistor. We never used I3, and we didn't need to know what it was. I think this is not the required part of this solution, but we'll go ahead and find I3. If I do junction, that's Kirchhoff's current law at A, at junction A there. I don't know if that looks like a junction A or not. There we go. It's getting a little bit worse. Lost my connection there. But to Kirchhoff's current law at A, we got coming in as an I1 minus an I2 because it's actually leaving, and minus I3 because it's leaving. So solving that for I3, that's I1 minus I2, or what do we get for I1? 0.050 amperes minus 0.01 amps. So that's a 0.04 amps. I3. Now, probably shouldn't even be boxing that one in because they didn't actually ask for that one. That was just acro. So you could use junction to get I3 if they had asked for it. It's not going through any resistors. That's why we didn't need it. It didn't appear in any voltage changes in either loop 1 or loop 2, even though we went through that part. The voltage change is fixed by the C to V